Improve your data science and machine learning skills by completing Kaggle competitions. In this course, Rohan Kumar will teach you how to solve 3 different Kaggle problems step by step, providing valuable insights and practical knowledge.
In this tutorial, we will be showcasing 3 different Kaggle projects that will give you a brief idea on how to approach Kaggle problems, which closely correlates to giving you experience of how to solve real-world problems. According to me, Kaggle is a premium tool when it comes to data science and machine learning, and it is available for free. And speaking of machine learning and data science, I run a channel called SMDS, where I primarily post videos about machine learning and data science itself. In fact, this entire tutorial is an illustration of our ongoing Kaggle series, where I post videos about taking on Kaggle competitions, starting from the beginning and going all the way up to the submission file to have a look at our leaderboard. And that's how we will be doing all of these 3 Kaggle projects. And I also want to mention that at the time of recording this, I'm focusing on giving you a perfect computer vision playlist inside of our channel, and that also contains a lot of Kaggle competitions as well. So you definitely do not want to miss out. Make sure to leave a link to that in the pinned comment. Now, with all that said, let's just get into the first project itself. All right, so here I am in the main page of the competition itself, the Kaggle competition. I'll make sure to link this down in the description box below. And over here, what you have to understand is we will have to basically predict the housing prices based upon some given variables. And for this case, and since this is advanced regression techniques, as the name suggests, we're going to have 79 explanatory variables describing each and every aspect that we will need to make predictions, right? So as I get to the data tab, here they have given us the information of the files that we're going to be downloading. There will be a training set, test set, and then there's some sample submission CSV file as well. And then they have given us information of each and every single column or the feature that we have. So if you're going to spend 3 to 5 hours in this project, this is what I would recommend you to do. Just understand each and every single column and try to create some interesting features with these. That is, just perform extensive feature engineering and then take it to the next level in terms of predictions as well. But for our case, in this video, just for the sake of simplicity, I'm going to deal with the none values, just perform basic data analysis and manipulation, and then go to prediction directly. All right, so here that we've got information of every single column, and then we have the actual visualization of the data itself. This you will only get to see once you join the competition. So when you click on join competition, it's going to ask you for confirmation. And as you do this, you will be able to be a part of this competition. Right, once you do that, it will refresh, and then you can go down to the data tab once again, and then now you'll be able to see the sample of the trained CSV itself. Now, there is only one thing that is not going to be present in the test CSV, that is going to be the sale price. This is the one that we have to find ourselves. I don't think so it's available here. You just have to find the sale price column. All right, now this is not going to be available in the test set, because that is the one that we have to predict and then give it as a submission. And they've also given us a sample submission CSV file, the things that they're expecting. They expect a sales price column, and then they also expect an ID. All right. So after you've gone through all of this, just click on download all. That will give you a zip file. You will extract it to a specific folder. Now, I have come to my VS Code, and this is my Jupyter notebook. Here I've written all of the code down. I'll be explaining it line by line. But basically, after extracting all of those 4 files to a specific folder, I recommend you create your Python file in that same folder so that you don't have to extensively copy the part to read it inside. I'll let you know what I mean when I get there. All right, so first thing that I'm going to do here is import all the dependencies that I need. So we'll be needing pandas, numpy, and matplotlib. And I've also imported C1. This is another data analysis package. Again, if you haven't installed, just go to your terminal and type it pip install and your library. All right. So after that is done, I am learning what's my data. So now I'm going to use the read CSV function from pandas, the train set, and the test set. All right. So I'm going to call VS1 as train set. Now inside of test set, I have created a filler sales price column. And the reason why I'm doing this is I'm going to merge these 2 columns initially before I perform a data planner or data manipulation. And the reason why I'm doing this is you always have to make sure that your test set and your train set come along in the same domain. And the main reason why I'm saying this is, let's say you do some EDA, or let's say you do some data manipulation on train set alone, and some of the features that might not be available, or some of the none values that pops up in the test set but might not pop up in the train set, will not be dealt with if we just work on the train.tsv. So I always recommend you to merge these 2, put them in the same domain, and then start with your exploratory data analysis. And later, everything is done, you can split them again into DF1 and DF2. All right, so first what I've done here is loaded those two in. You just have to copy the path of the train CSV and the test CSV and put it over here. And then create a dummy sales price column, just initialize everything to 0. And then use the pd.concat function, put them inside a list, df1 and df2, and then set axis equal to 0. This does mean that we're going to vertically stack those. We're not going to do that horizontally. They just have the same amount of features. It's just the number of records that is going to increase. All right. And then I've set the index to ID because that is going to have every single unique value. Now, when you run this code cell, that's going to create our main data frame. And then when you type in df.head, as you see over here, we get our first 5 records of the data set itself. Now, here we have set the ID as the index, so that pops up a little bit down. And then it shows 80 columns, 79 features, the sales price column, and the ID. All right, so after that is done, the next thing that I'm going to do is find all of the none-value columns. That is basically, if a specific column contains none value, then I will extract it and put it inside a new data frame. All right, so let me show you what I mean. So this statement writes here, I just want you to look at the one that I'm highlighting right now. Now, this basically means this will show us all of the none values in each and every single column. And I'm setting a condition that if it is greater than 0, that if at least one none value is present in a specific column, this will show each and every single none value. I can just show that df.isNA.sign. And let me just run this code cell. You have to put in it about like that. All right. Now it shows that each and every single column, the amount of none value is present. Now, if it is 0, then we're not worried about it. So I've set in a condition that if it's greater than 0. So let me just show you what happens when I do this. I did this, it gives us a true or false value, a conditional value, just like a mask. And I'm going to do that, put that inside of the slicing condition and do the same comment once again. So this time, we're going to get all of the columns. Actually, let me just copy this and show you. All of the columns which contains at least one none value. So when I paste this and run this code cell, I'm going to get all of the columns that contains at least one none value. That is what we're going after. And this only displays the none values in each and every single column. What I want is the index of that. So I'm going to retrieve the index and then extract that from our data frame and store it in a data frame called df_null. All right. So now when I run this code cell specifically and then do this, we're going to see the 34 columns that contain the none value, and those will pop up right around here. All right. And then now I'm going to check the heat map, that is the amount of none values. This will give us a good understanding of the none values present in each and every single column of the df_null. So when I run this, it gives us the exact heat map that you just saw. And as you see over here, let's take the LA column, for example. There's just too many none values, and so is for the pool QC. So we can safely remove all of these columns where all of the none values are just extensively high. All right, so what I've done here, I've gone on ahead and created another data frame, and it's called df objects. All right, what I mean by objects is all of the columns that contain only just string values or other values that is not numbers. For example, this doesn't come under object, this comes under float. All right, but this comes under object, and this comes under object. So I'm going to create a data frame which contains all of these object columns alone. And the way I'm going to do this is by using the df.select dtypes function, and then I'm going to include only the object data type. We retrieve all of the columns out of it and then put that inside the df entirely and then store it in a data frame objects. All right. Now, so this does mean that I'm first dealing with the none values of the objects column. That is, I'm dealing with the none values in the columns which are only objects. And right over there, I have just done the same thing what I've done over here. Like basically just setting the condition to more than 0. That is, I've set the condition over here to 1100. That is, if there is 1100 none values, then it's not going to give us much of a value. So I'm just going to drop it directly. All right. So use the df.isNA.sum and then mention the condition just like a mask, retrieve the index just like we did above, and then retrieve all of those columns. Mention axis equal to 1 as you do df.drop. All right. Hopefully that makes sense. So we have created df objects, and then I have also dropped off all of the columns in the objects where the none values which is greater than 1100. So let's just run this code cell. Perfect, that is done. All right, I've done the same thing. This is done on the main data frame. I've done the same thing on the df objects data frame, just basically removing all of the columns where the none values is just greater than 1100. And then we are going to fill NA values. All right, so basically now our df objects, let me just actually cut this and type in df objects.head to show you. .head, you run this code. So now this objects data frame will contain only those columns where the none values are just less than 1100. That is, we can at least get some value out of it. So those are the columns that we have in this df objects dataset. And what I'm going to do here, let me just paste that once again. In those columns, I'm just going to fill all of the none values. And what I mean by that is, let me just see if I can find some. Nothing. All right. So I'm going to fill all of the none values by a string named null. Let me just show you why I do this. All right. So let's say I take this utilities column, for example. All right. So I'm going to access those utility columns. And then when I type in value counts and then come over here and see, there is only two categories of values in this utilities column. It's either all PUB or no saver. And no saver is just one value. And apart from this, there might be none values in this utilities column. So what I've done over here is actually, let me just cut this and run this code. So I'll show you. What I've done over here is fill all of those none values. Let me just do that and come over here and do this. And now we see that we have a new category, null category. So now we will have three different categories. And why did I create this category? Is because I'm going to do one-hot encoding. So basically what this means is, like right as you see over here, the utilities column will have three different types of values. It's either all PUB or null or saver. So what I will do is create three new columns for each and every single record. And for that specific record, if they belong to all pub category, then off of those all pub, null, and saver, all pub will have 1, and then null will have 0, no saver will have 0. But then if the null value is true, that is, if null seems to be the category for a specific record, then null will be 1 and the other two will be 0. And this is known as one-hot encoding. You can just directly do that by using the getDummies function in Pandas. All right, you just have to pass it in the data frame, and that will create a specific new data frame. I'm just going to call that dfObjects.encoded. So let me just run this code cell once again. And after I've done that, I'm going to come over here before we get to this code cell. Let me just type in df encoded objects encoded .head. I just want to show you the first 5 records of the encoded objects. All right, so right as I see over here, we've got 247 columns and creates different categories for MS zoning. Like MS zoning might have, in fact, let's just go ahead and type in MS zoning. And then as we see, there is 5 different categories, right? Including null, it's 6 different categories. And that's what is created here. So for the first record, if it belongs to the RL category, then RL will be true. But then everything else in terms of MS zoning is 0. So now we have 6 new columns out of this MS zoning column alone. And that's what I've done here with every single column in the df objects. Right, so that's how you deal with it. And then what I've done here is I want you to notice this column over here, this MS zoning null. Only if other 5 of them are false, then this one will be true. And we don't have to extensively mention this to the model while training. So what I've done is I have deleted all these null categories columns. So what I've done here is gone on ahead and looped over the entire encoded data frame columns. And then if null is present in those columns, then what I've done here is just dropped off those null column, mentioning access is equal to 1. And I've also made sure that I'm printing it. So when you run this code cell, you're going to see all of the dropped off column and it all has got null. So you don't have to extensively mention this to the model, but if you do wish to do that, it's actually okay to do so. All right, so this is kind of an optional step, and I've done this. The new data frame that I've created over here, this is the new DS, and over here, it has got 304 columns, and I only want the columns which are not objects, because we have dealt with it, and we have created too many Boolean columns as well. So what I've done is access the main data frame object columns, and then drop that off from the new data frame. And then now I have set the condition once again, checking for null values in each and every single column, and if it turns out to be true, these are the ones. So basically what we have done here is our new data frame contains only numerical columns. That is, the columns which only contain numerical values. It's either 1, 0, or any floating point numbers. So those are the columns that we have. And over there, we have got so many none values in these columns. So we have to deal with all of these. And what I've done over here is, again, let's just run this code cell. And what I've done over here is created 2 new lists. I've named it mode columns and mean columns. This basically means I've created a list of columns for which I'm going to fill all of the none values with just mode. That is, I'm going to find the mode of those columns and use it to fill the null values. All right. And then when it comes to mean columns, I'm just going to find the mean value of a specific column to fill in the null values for that. The way I've decided if I want to find the mode or if I want to find the mean is by just looking at the column, house prices, and then go to the data to look for a specific column and then see what kind of definition have they given. For example, in our case, let me just go ahead and see for garage cars. So to show you, all right, so garage cars, the size of garage in the car capacity. So that means that we can't find a specific mean value for this. What I've done here is gone on ahead and I'm just going to decide that I will have mode values for this. So that's how I've decided for each and every single column that goes under mode and the mean. All right, so just looking at the columns, trying to identify what it means. All right, and then I have looped over all of the columns and every single columns. I have used the fill NA function. That is just, again, you just have to see that new df of I, I'm again accessing it with the fill NA function and then finding the mode of it. Just make sure that you're accessing the 0th element that only gives you the mode. And similarly, I have done that over here as well. I've just used the numpy round function, just making sure that I don't get a floating point number and finding the mean for each and every single column to fill in the none values over there. All right. Now, when I put in this condition, it should not give us any columns and it gives us an empty list. So there is no none values whatsoever inside of our entire data set. And I've called this the new df. So the final data frame that we have after performing pre-processing is new df. Now, try to remember that I've split the training data, that I've merged the training data and the testing data together before performing any type of exploratory data analysis. So now it's time for us to again split them up into df1 and df2, and I'm calling this the testing data, the training data. The training data will be the len of df1. That is, it's going to start from 0 and then find the length of df1 and then get the exact length of all of those and put that in the training data. And onwards, that is from the length of df1 till the end will be the testing data. Because remember that we have vertically stacked the training data and the testing data. So on top of the testing data is going to be the training data. So the first initial set of columns will be of df1. And then from df1 until the end will be to the testing data, that is df2. All right. Now our testing data, we don't need the sales price column anymore. So I'm going to drop that off as well. All right. So let's just run this. And now we come to the model training section. All right, here we specifically select a few algorithmic models and then train the model based on the given data. And then we decide how the model performs based upon some metrics. And then we will go on ahead to create a submission CSV file and give it and submit it on the competition. So here a lot of imports are happening. And the first dependency that I'm going to show you is the train test split. This will split the data. Let's say I'm taking the training data over here. I want to split this into train and validation. I will be providing around 80% of the data to train the model and then 20% of this training data, because we have the labels for these training data, to test the model on the training data itself. That is the rest of the training data. I'm going to call that validation set. All right. And then I have imported metrics mean squared error. This is the metric that I will be using to see how well a model is performing or how dumb a model is performing. All right. You can choose any other metric as well. There is F2 score. There is many others. So I've just gone on ahead with the mean square error for simplicity. And then I'm going to be using 3 different models and see which one performs the best. All right. So I've gone on ahead to import the linear regression from the linear model. There's also polynomial regression you could try out, which I recommend you to do so. And then from XGBoost, this one turns out to be my favorite. From XGBoost, this is just gradient boosting. Again, just make sure to pip install XGBoost. So go to your terminal and type in pip install. That will install the XGBoost algorithm, where it's got XGBoost regressor and XGBoost classifier as well. We have talked about that in our previous video. And then I have also gone on ahead from scikit-learn and Subble. I have imported a random forest regressor. There is also a random forest classifier, which you can do for classification tasks. All right, so import all of these. And once that is done, now I'm going to split the training data. All right, so I will be dropping off the sales price column just temporarily, just to set this as the training data. And then the output label, Y label, will be the training data's sales price. All right. Now, here I haven't mentioned in place equal to true. So this is not going to just directly delete the sales price column off of the training data, but then it will extract that out of it and then put everything else in terms of X. And then as I'm accessing it on the Y label, it stores that on the Y. All right. And then I have created X train, X test, Y train, and Y test. And this X test and Y test will be out of our main training data only. See, as I want you to notice over here, we've created X and Y. All right. We've used the train test split function. You pass an X, Y label, and then you want to mention the test size. That is the validation size. If you mention 0.2, that means that you will get 20% of your entire data for testing. All right. So X train will contain 80% of X and Y train will contain 80% of Y, and the rest goes on to X test and Y test. And then I have used the reshape function because generally when you see Y train's shape before doing this step, it's just going to be a one-dimensional rather than being two-dimensional. And our model expects always a two-dimensional array in terms of understanding data. So I've done that for Y train, and then I've also done that for Y test. And then now when I run this code cell, if I type in xtrain.shape and ytrain.shape, it gives us this shape, and then we want it to be two-dimensional and make sure that the number of records match. All right, so this one basically means the output value that we're trying to predict. All right, so the first model that I'm going to have is linear regression. We have imported that above. And then you just have to type in, actually first, as you define the model, the basic format is always going to be to define that model and then use the fit function and then use .predict function. All right, so first you create the linear regression model and then you pass in X and Y. Of course, you could pass in the X train and the Y train, but we also have a specific testing data, which is what we're going to try to predict on. So what I've done here, you could try out the X train and the Y train, which I actually did, and then see how the model performs on the test set. So let's just try that, put that X train and Y train, and then run this code cell. We have to put this in capital. Now we get a pretty high mean squared error when I compare that to our model 2. Now model 2 has a few hyperparameters. First thing is going to be n estimators. How many estimators do you want in terms of gradient boosting? And then you also want to mention the learning rate. Again, and random state is an optional step. Let me just remove that to set a random seed. I'm going to have that. Learning rate is basically how fast you want to take the next step in terms of learning. Again, if you're familiar with the gradient boosting algorithm directly, then you will understand what learning rate is. So basically, you just have to mention two parameters. Two hyperparameters, as you mentioned. You create XGBoost regressor and then use the model.fit. Again, pass in the train data first to see how the model is performing over there. Capital Y, right? All right. And then see the predictions for the X test, that is the 20% of our training data. You use the mean square error function. You first pass in the actual label, and then you also pass in the prediction label, which is we made over here. Model2.predict actually does that. All right, as we see over here, the model actually performs better than the linear regression model itself directly. But again, this gives us a very, very high value. So as I try for the random forest regressor, again, you have to mention the number of estimators that you want in terms of this algorithm. And as you get the regressor function, again, you just perform the same steps and see how the model is performing over here. Again, just make sure to put in train. All right, make a prediction. All right, now we get the random forest mean square error as well. And this seems to be higher than the XGBoost regressor. And in terms of mean square error, we want to make sure that the number that we get is always lesser. So this model turns out to be better than the other two that we've decided. So what I'm going to do now is just, rather than giving the train set alone, I'm just going to give the entire training data set because we want our model to train on this. And then now see how the model is performing. Again, we see that the values drop, the mean square error values drop significantly. That's because we're giving in the entire data. I'm just going to do the same thing for our second model, that is XGBoost regressor. And then run this code sum. All right, and here as well, we see the value drop off significantly. And then I'm just also going to do that for random forest because we just have to provide in the entire data set in terms of training to train our model perfectly, and we make predictions on the testing data alone. And what I mean by testing data is this one. And what I mean by X test or Y test is the test set that we created from our training data. All right. So as I see over here, once the model is done training, we get the mean square error. And again, this value does drop off, but again, it seems to be very, very high. So when you compare this to other two, XGBoost regressor does significantly better. So that's the model that I'm going to take to make predictions. And also, this is just for visualization. You don't have to actually understand this. This is kind of an optional step. You could do any type of visualization if you wish. I'm just going to delete this. And I have selected model 2. As I saw, it has the lowest mean square error. And then I have used the predict function, passed in the testing data to get predictions. And I want you to remember the sample submission CSV file. In fact, let me just go over there. our sample submission CSV file should contain the ID and then the specific sales price that we are predicting. All right, so I'm just going to go over here. And then to get the index or the ID itself, the testing data.index, that is our final ID, because since we have set the index initially to ID over here in the very first line, in the very first cell of our data analysis, we have set the index as ID. So this column will be set as our index, and right as we split that over here, we can just directly access that index. That index will be the ID column from the testing data, and then I've called that column as ID. So first, after creating an empty data frame and calling it final, the final of ID, that is creating a new column ID, I have set that with the index, and then I've made predictions accordingly with the testing data and set that as the sales price column. Now, we don't need a specific index column. We have the ID itself. So we have to mention index equal to false when you're typing in final to CSV. That is, it creates a CSV file. I've just called that output.csv. And then you don't need a specific index. So when you run this code cell, I'm going to create an output CSV file. As I open it, we get only two columns, ID and sales price. Whereas when you don't mention this, let me just show you what happens. Run this code cell once again and go over here. Just do this. Now we get another additional column, which is the index, which is not what we need. So I'm just going to close this and make sure that I type in index equal to false like that and run this code cell once again. So now we have an output CSV file, which we can submit for prediction. And the way you have to do this is go to your home page of the competition itself. And over here, just click on submit prediction and navigate through to your folder where you have the Python file. And then from there, you can just select the output CSV file. But let me just do that quickly. The output CSV file, I'm just going to drag and drop that over here and then click on submit. And there we go. Our submission is successful. We have got a score, and this score has to be as low as possible. So when I go to my leaderboard, and then when we jump to our position, it puts us at 1458, which is pretty decent. And we got many others at the same number as well. And the number goes down further as well. So you want to make sure that you have minimum amount of error. If you can achieve this type of error, that is actually really, really nice. And if you wish to do that, and what I recommend you to do so is just go over here and identify and understand every single data column and trying to create feature engineering and trying to just manipulate the data much more. It's all about manipulating the data rather than finding a perfect model or an algorithm. All right, let's have a quick overview of the problem statement itself. Here they've given us a brief introduction about the problem, but basically what you have to understand is around 13,000 people are traveling in this spaceship Titanic, and we have to identify for any given person if they have been transported to the desired location or if they have been put into the alternate dimension. And here we have all of the data columns, or the features, if you will, and the transported column is what we have to predict. So if the person has been transported, which in this case will give us true, and if they have been put to another dimension, then we will get the output as false. Now, I recommend you to look at all of the information given about the columns. It's just very important when it comes to feature engineering. So the way I'm going to approach this problem is by two things. I'm going to be using KNN Imputer to pre-process the data fully, and then we'll be testing out different models to see which one performs better. Again, if you don't understand what I mean, I'll make sure to show you how I implement it line by line. So with that said, now we just have to download all of this data. There's three files. There's train, test, and CSV. The test file will obviously not have the transported column, and the submission CSV, it's just the expected format of which we have to submit. We will have to have in the passenger ID, and then we will have to say if the person has been transported or not. It should be a Boolean value. All right. So after going through all of this, just make sure to click on download all. It will install a zip file, and then you have to extract that to a specific folder. Now here I am at VS Code, where I've created a new folder, Kaggle not2, and that is where I have all my three files. All right. Over here, I'm just going to create a Jupyter notebook. Again, make sure to have the Jupyter extension installed of VS Code, and then just type in main.ipynb. Now this is going to create a Jupyter notebook, and make sure to select your default kernel. By default, it's just going to have the base Python installed onto your local machine. And now after we've done all of that, we can just get into the main code itself. I'm going to be starting off with importing all of the packages that I need. We'll be needing the standard pandas, numpy, and matplotlib. Then I'm also going to be importing Cbon as SNS. Thank you, Copilot. And then the main tool that I mentioned earlier, we will be importing KNN Imputer. I'll just tell you how it works as we get there. For now, I'm just going to import it like that. And now make sure to run this code cell. These are the ones that we will be needing to perform the pre-processing step. After this is done, we will get to the machine learning step where we will use multiple different algorithms and test out different models and see which one does perform better. Now, after that is done, we can now load in the data and then name it a data frame. So I'm going to first call in the train data frame, which will be pd.read_CSV, and then just the train CSV, because as we look over here, we've already bought in the train CSV and the test CSV together. So let me just load in a test CSV as well, like that. And then once that is done, I'm going to create a dummy column inside of the test set, because that is a column that will be absent in the test set, and that is what we will have to predict. So what I will be doing is fill it all with false, like that. And then, now before performing the pre-processing step, this is the most important thing that you have to keep in mind. You have to concatenate these two files to put them in the same domain. Just make sure that whenever you're doing a machine learning problem, you just have to put all of the data sets, all different data sets into a single domain before pre-processing, before performing any sort of data manipulation. All right. Now, to do this, I'm just going to call it a main data frame and then use the pd.concat function to concatenate the train and the test set. All right, just make sure to put sort equals to false. I don't want to sort it like that. And then let me just see the actual data column itself. Now, when you do this, we have to get the top 5 records of main data frame, and it shows us how is it available. All right. Now, just to make sure that we have concatenated properly, let me just type in df.shape must be equal to, actually, df.shape of 0 must be equal to df.trains, df train shape, and df test shape. Now, this should return true. And if it's true, that means that we have concatenated perfectly. All right, now as we look into it, we just see that we have all the different columns. Now, the immediate next step is just going to be identifying all of the none values in each column. So, main function that we're going to be using to identify this is just typing in df.isNA.sign, like that. And when I run this code cell, you get to see the number of none values in each column. So I recommend you to deal with all of these none values column by column rather than using a simple algorithm like KNN imputer or simple imputer. But for the time being, I'll be using KNN imputer. It's a much efficient way as well. So now for this one, I'm just going to go back to our overview page where we have to understand the data itself. Now over here, I want to see the cabin column, because as we see on the dataset, the cabin column has values that looks like this. And the information that they've given us here is the values are in the format of the deck, number, and the site. So we have to separate them into 3 different columns. Let me just copy this. So we will have to separate this into 3 different columns, one as deck, one as number, and the other one as site. So in order to do this, what I will be doing is using regular expressions to extract the exact string based upon the /. And to do this, let me just show you our df, which will get 3 new columns, deck, comma number, which will be first access to df cabin, then from here, convert this to string, and then use the split function. And then we want to split it in terms of the /, like this. Then type in expand equal to true. Now this will create 3 new columns, just like that. And those 3 new columns will be named as deck, number, and site respectively. And then we can make sure to drop our cabin column, columns equal to cabin. That's about it. Now let's just run this and then go over here just to see our df.head. Let's create it over here. Just type in df head. And now we should be having 3 new columns while the cabin column should be gone. Yep. So we get deck, number, and site. Now the next thing that I'm going to do is deal with these none values first. Now if you run this code cell once again, you'll be seeing that you get 3 new columns over here. And I'm going to deal with these 3 columns none values first. And the reason why I'm doing this is because at the end, I realized that this gives me much better accuracy, but then you can try this with simple imputer as well, as I show you how to. Now over here, df of deck will be df of deck dot fill NA. This function will help us to fill all of the none values with the value that you're mentioning. Then I'm just going to use u. So all of the none values. And the reason why I'm doing this is actually to show you df of deck dot value counts is the function that you can use to identify the number of values in a column for each and every single category. Actually, this is a little bit bigger. Let me just show the side. Yeah, so when you use the value counts function, it will show you the different categories available in each column and then their values. And this will be sorted from top to bottom. All right, so let me just try that for the home planet, show you a much better example. Again, home planet is the column which says that the original location of the passenger itself. There is a bunch of Europa, Earth, and many more. And when you run this code cell, Oops, you just have to put in this. Now when you run this, it gives you that there is 3 different categories and then their respective values available. So now when I fill the none values with U, there is a new category created, which is U. So let me just run this code. So once again, actually we already extracted the cabin column. So what I could do is let's just run all of these code cells once again. Click on run all. All right, now we have filled all of the none values with U. And now when I put in the value counts back, we get a new category which has all of the none values. And now when you run the isNA.sum function, it will give us no none values, which is what actually we want. So deck is dealt with like that. And this is numbers column, so we have to fill it with a number. Then what you could potentially do is just have the number column filled. Fill it with something like -1. And then I'm just going to do the same thing for side as well. Just add a new category. df of side. And just type in new like that. Just going to cut this actually. Rather than doing that, let's just click on run all once again. All right, now as we see, now let me just run this code cell once again to show you that there is no none values for the 3 columns that we had. And then now what I'm going to do is something called as label encoding. All right, there's 9 different categories in deck, and I'm just going to convert all of these categories into numbers. Let me just get to this code cell. The way I'm going to do this is first access this deck column, then over here, use the map function, df.deck.map, and then you can use a dictionary inside of it. Basically going to start with G. Now G will be termed as 0, and then put a comma, F as 1, and you basically get the idea. You're just going to convert all of these categories into numbers, and those numbers will have these values. And then finally, T will be 8, like that. Then after this is done, I'm also going to do this for the side column as well. Side as only, I guess, 3. So let me just see. 3 different categories. Yep. So there's S, P, and U. So as we access the side column, after mapping these 2, let's just run this code cell. And then now we can basically get to K and an imputer. Now what we can do here is first define a set of columns which will have all of the numbers. So let me just show you actually. Now, if you look at all of the columns available, now here we see that the name column will never be numbers. It's only going to be object. Again, let me just get to the data frame itself to show you. And then this home planet is object. This destination column is an object, and rest all will be numbers. And then what I'm going to do with the name column is just basically drop it. It's not going to give us any sort of value towards getting to the final output itself. So I'm going to just drop the name column from the data frame itself. And then we're not going to consider destination and home planet for now. We're only going to take all of the numbers and the Boolean values together and then use the KNN imputer, because KNN imputer works only best with numbers. So what I'm going to do here is actually first just type in df.drop. Let's just do that over here. df.drop. Name is the only column that we're going to drop. And then get over here. And then I'm going to create a list of imputed lists, which will be all of the columns that contains numbers. So the columns that contain the numbers will be age. All right, here I've included all of the columns, just basically ignoring the home planet and the destination. Those 2 are going to be objects, and then we have already dropped the name column. And then we will not be needing transported column. So other than that, every other column has been included over here. And then we're going to be giving this to the KNN imputer to get the updated data set. And then the rest is going to be, let's just create another list of. Let's access all of the columns that is available in the data frame, and then take off the impute list like that, and then convert this to a list. So this is the rest of the columns that is not inside of impute list. And then let's create a random data set. Will be df of rest like that. Now I'm going to create a new variable imp, and I'm just going to name this to be KNN imputer algorithm. Imputer. Now, KNN imputer works based upon the amount of neighbors that it is going to consider before updating the data set. So you can just type in neighbors. And basically what this will help us do is fill off all of the none or the missing data based upon looking at the other data set using the nearest neighbors algorithm. Now, by creating this as an algorithm with n neighbors set to 5, we have now an imputer which will take in our data set, which will only take in the columns that we have mentioned over here. And then based upon looking at that, it will fill all of the missing data. I hope that made sense. And the way we can implement this is by using, let's just create an imputed data frame, just type in fit transform, and then send the entire data frame with our imputed column. Call this like that. This is the data set that we're going to give to our imputer, and it's going to fill all of the missing data that is inside of that. And then I'm just going to update this data frame to a data frame itself by using pd.dataframe. By using the pd.dataframe function, you can just convert the imputed transform data to a data frame itself. And then you just have to mention the columns as well, because you have to have a name for each column, and that will be as same as we mentioned over in this side, inside of this list. All right, so after that is done, what you could do is just update our main data frame. All right, so now what I'm going to do is take this data frame and this data frame and combine it to get back our initial data frame. So to do this, let me just redefine our data frame. Again, use the concat function. And basically, we're going to be concatenating the df imputed and the df rest. This is the rest of the columns that is not inside of this imputed data frame. So to make sure and get back the original data frame itself, we have to make sure that we don't give index to this imputed data frame and this rest data frame. So to do this, what we could do is just put this inside of square brackets first, df of rest, and then type in reset index. Now we don't need this index. And then just mention drop equal to true. And then do the same thing for df imputed as well. Just type in reset index and then type in drop equal to true. And then as Copilot suggested, you have to mention access to be 1 because we're combining it horizontally. We're getting all of the columns back to our initial dataset. All right, so let's just click on run all. All right, we get an error saying that n neighbors is not an argument which we get to mention. I guess they have updated that, but it just works on the nearest neighbors. And traditionally, we should be mentioning the number of neighbors, but for this case, it's not working. So let me just remove that and try. This time it should hopefully work. All right, now it worked. So if you go to this command over here and run this code cell once again, now this time we should see all of the none values vanished except for the 1 and 2 column, that is the destination and the home planet. And to fill this none values, it's just basically the same. We're going to just fill it with U, just like we have done for the deck and the side column. Let's just get to the code cell and then type in df of home planet. Just update it. Will be, instead of unknown, let's just have it to be U. And then do the same thing for destination as well. Fill it with U. And then run this code cell. Now, this should deal with all of the none values instead of every single column. So when you run this, this should give us all zeros. This is what is the initial step of data cleaning. And if you've done this, it's really well done. And as I said earlier, what I recommend you to do is just look at all of these columns, try to identify what value it provides to the final output, and then try to fill the none values accordingly. But then I've used K&N Imputer. It's just much faster and efficient way to do so. And it's actually much reliable as well. So after we have done this, now we can get to feature engineering, which is just basically creating new features for our model to better understand the data. Now, for this, again, let's just get back to our data over here. And basically, I just want you to look over here. All of these 5 columns just relate to the amount spent by the passenger to get the luxury amenities. All right, so what we could do is these columns are just numbers of the passengers in terms of money. So what we could do is just try to add up all of this and create a new column saying this is the total amount spent by the customer. And we can also find the average of it. And the way I've done this is first defining a list with all of these column names. These are the amount columns. And now I've created a new column, df amount spent will be first give the bill calls and then use sum function access equal to 1. Now this will calculate the entire values amount and then give us a sum back. And I'm also going to find the standard deviation. Now that also gives us good value in terms of providing it to the model. So what I can do is just use the standard deviation function and get the standard deviation for all 5 of these columns. And then I'm also going to find the mean as said earlier. Now these 3 columns have been created solely based upon this bill calls. All right. And then I'm also going to create 2 new columns based upon trying to identify the correlation of each of these columns with the transported column. Now, if that doesn't make sense, then what I recommend you to do is use this function. Actually, let's just go over here, df.core. And then when you do this, it's going to give you a heat map kind of numbers, but then it's not going to be in the map format. And gives us an error. Oops, I forgot to mention one thing. So as we filled all of these none values, now we are still not left with numbers for these 2 columns. As we look at the data frame head, let's just go over here and type it out. Now, as we see, this destination column is still object and this home planet is still object. Again, passenger ID is not something that we're worried about. So what I can do is again, these are categories of values. So let me just use the value counts function once again to show you. As we go to the home planet and then run this, we've got 4 different categories. Now, what if I create 4 new columns out of this? And this is called the one-hot encoding. Now, if I just show you for the destination as well, destination, and then run this, there is, again, 4 different categories. So what I'm going to do is convert this destination column, which is termed as 1, which has got 4 categories. I'm just going to convert that into 4 new columns. And the way I'm going to do this is, let's just get to this code cell. And then let's just say I'm going to create a category called list. And this will be left with home planet and destination, just like that. And then now I'm going to use a for loop to loop over that for in category calls. We just use the copilot statement and explain it. Our updated df will be, we're going to concatenate the initial df and then what this dummies function does. Actually, let me just take this alone separately. When you do this, now this will create the thing that I mentioned earlier. It's just going to convert all of those categories into new columns. So when you just try to do that, let me just actually print it. All right, now as you see, there is a new column created, a new column, and then a new column, and then a new column. And this is for the destination. And then this is for the home planet. Now, look at the prefix is going to be the home planet itself along with the category name. And this is what this pd.dummies function will be doing. And what we're doing here is all of these new columns are being put onto our main data frame with the suffix of all of these 4 new columns will be added to our main data frame using the df concat function. Hopefully that makes sense. I'm just going to remove this and then take off the docstring like that. And then also make sure to mention 1 because we're going to be combining that horizontally. All right. So now when you run this, this should combine 4 new columns from home planet and 4 new columns from destination to our main data frame. So let's just run this. All right. Not this one. Yep. So as we get over here, it says that the code is run successfully. Let's just try to give df head. Now I feel like our entire data set should only contain numbers except for these 2 columns because we don't need these 2 columns anymore because we have created 4 new columns for each of those 2. So what we could do is just drop these 2. And let's just get over here. And since we have it already defined, we're going to just type in category calls. All right, let's just run that once again. Actually, put it inside of this code cell over here and then run this. All right, so once that is done, now our data set should only contain numbers. There is nothing else left with our data set. There's only numbers as we look issue. And then passenger ID is not something that we're really worried about. But then since it contains numbers with an underscore, it means I'm just going to drop it as well. So let's just go over here to our very first line of the code. And then we type in trunk passenger ID. Now let's get to this section and then click on run all. Now this should give us the correlation. And as we see over here, you're not going to most probably understand what is given over here. But what we need is the correlation of all of the columns with the transported column. So this is the only line that we have to look at. And to be more specific, what you could do is just get over here and just type in transported, the column name that you're looking for, and then just put ascending equal to false. This gives us a much better understanding. Now, as we see over here, now transported column is just much more ordered out by transported. So that is, if transport is 1, then obviously transported is going to be 1. But then as you look at the cryosleep column, that is, if cryosleep is termed as 1, then there is a very high chance, there is a 32% chance that the person has been transported to the desired location, because that's what we're trying to identify with this correlation column. Now, and if you look at the home planet Europa, that has 13%. And then as you scroll down, come back to the negative correlation. That means that surprisingly, if a passenger has paid more on the room service column alone, then that means that they have a 17% chance that they're not transported to their desired location. That's how we are going to be creating 2 more new columns by just looking at this correlation. What I could be doing is name this to be 3 high calls. And then as we look at it, there is cryosleep, Europa, and this destination. I'm just not even going to try to pronounce it. I'm just going to combine these 3, add these 3. These 3 are just true or false categories. So if these 3 are true, that means that it's 3. It's going to return a value that is 3. Again, let me just show it to you. df of cryosleep, follow that up with df of home planet Europa, plus df of destination. All right. And if all these 3 turns out to be true, then that will give us an overall value of 3. And if the value is 3, then there is much higher chance that they're going to be transported. That's what we're trying to accomplish here. And then I'm also going to create 2 low calls as well, just to make sure that it works. Low calls. as I look at it right around here, these 3 columns have been already used to create a new feature. We have put that inside of this build calls, and then we have created amount spent, standard deviation, and mean. So we're not going to touch these 3, but then we will be trying to get it from right around over here. All right. So we're going to be using this column and this column together, the amount spent and then the mean amount spent. That gives us a new column as well. So what I'm going to do here is just go ahead and type in mean amount spent like that. And then I'm also going to add standard deviation amount, maybe the total amount spent. And then I'm also going to add the own planet. So let's just name this to be 3 low calls itself. And then df of amount spent. And then instead of VIP, I'm just going to type in own planet Earth. Right? That creates a new column as well. So now let's just run this feature engineering step once again. And now when you run this code cell, we have another 3 high calls, which gives us a very positive correlation towards transported. And then there should be one over here as well, the 3 low calls, which again considerably gives us a very strong correlation with transported. Now this helps the algorithms understand better the data to make better predictions. Now that was the pre-processing step. That was data manipulation. And we're going to now going to be testing out all the different algorithms. And to do this, let's just import 5 different algorithms. I'll be creating 5 models and see which one is working better. All right, the first one is going to be from XGBoost. Again, you have to make sure that this is installed onto your local machine. I'm just going to import the XGB classifier. And then from sklearn.tree, we will be importing decision tree classifier. That's another algorithm. And then from ensemble, we're going to be importing random forest classifier. Then from linear model, sklearn linear model, the linear, we'll be importing logistic regression, the basic logistic regression. And then I will also be importing what I like the most, light GBM, and then LGM classifier from that. So make sure that you have scikit-learn, XGBoost, and light GBM installed. You just have to type in pip install and install all these 3 modules. And then we can import scikit-learn to split the training set into train, test, and validation. And then I will also be importing the accuracy score from scikit-learn metrics just to see how the model is performing on the training set. Now over here, we have combined the data frame train and test together and then perform the pre-processing step. So in order to get it back, data frame of train and test separately, what you have to do is get over here and then just type in df train, df test will be df of train shape.0. So from initial till the train shape.0, and then from there till the end, we can just have that to be test set. And then from the test set, what you could drop is the transported column. We don't need that anymore. All right, after that is done, just make sure to check if the shapes are matching. df train.shape, df test.shape, like that, and run Scotto. Now we get our initial train and the test column, like that. Very nice. Then now you can run this code cell, and we have all the different functions that we will need for performing train test, and then giving that to the algorithm, and then getting the accuracy score. All right, from here, I'm just going to create our X label, which will be df train.drop columns, and we don't need transported. Now notice that we have already dropped the name and the passenger ID, and then our Y will be, the Y label will be df of transported. All right. Now, I'm going to create a training set and a test set. The test set will be 20% of the entire data frame, and the train set will be 80% of the entire training data frame. That's what I have access over here, just getting the X label and the Y label. So this is what we're going to be providing to the model for training, the X train and the Y train. And this is what we'll be using to test the model. All right, to show you how it works, let's just create 5 different models. Our model 1 will be, let's just start with the logistic regression model. And then model 2 will be just basically calling all of the different 5 algorithms that we imported at top. Decision tree classifier. Model 3 will be random forest classifier. And then model 4 will be XGB classifier. Then model 5 will be LGBM classifier. That's my favorite one. So to run this, now we have our training set, test set, and then we have 5 different models. To train this model, all you have to do is just type in model 1. Let's show you model 1.fit. And then you will give an X train and Y train. And then immediately you will test out the accuracy score. Accuracy score, Y test, and this will be our model prediction. Actually, you can just put that to be thread, will be like this, and then put thread over here. So the predictions made by the model, and then the Y test, the actual Y label, will be compared and given us the accuracy score. And for the test set, our model is 77% accurate. And this is just the logistic regression model that we have tried out. We can just try out for model 2, model 3, model 4, model 5. And see which one performs the best. Now, I guarantee you all of the other models are just going to perform better than logistic regression. All right, because all of them use gradient boosting and the decision tree classifier algorithm. So Let's just try the same thing for model 2. Dot fit, pass in the x train, y train, and then pred will be model 2 dot predict, and then x test. You're going to pass in the test data set. That will give us the predictions. And then the accuracy score will be measured upon y test, that is the actual y label, and then predictions made by the model. And on this code cell, this gives us a 75% accuracy, and this is decision tree classifier. Okay, so logistic regression does perform better than the decision tree classifier. Let's just try that for model 3. This is going to be random forest classifier. Then again, Copilot is going to give us the prediction code. Then we will also get the accuracy score. Just the same thing. All right, and random forest gives us 79% accuracy. This is the best so far. Going to do that for model 4. Model 4 is the XGBoost classifier, and that does slightly better than the model 3 that we had, that is random forest classifier. But like GBM, like gradient boosting, and then something, we will have it as a filler, will, I guess, perform better than anything else. All right, let's just type in model 5, which is our light GBM model, because I've already tested this out. It's going to type in pred and then accuracy score. And after giving us a bunch of warnings, it's going to give us the accuracy score itself. And then it gives us 79.7 accuracy. All right. Now, the best that I was able to get was 80.9. And for that, I looked at each and every single column before dealing with the none values, trying to identify the entire data set. And I recommend you to do so as well. That gives you better accuracy. But then this gives us around 79.7. So I'm just going to take the best one, that is this model 5, and then make predictions for our test set and then give it as a submission. So the way we can do this, just type in pred equal to model 5. Just use the model that you wish, and then give the test data frame. After giving in the test data frame, I'm going to create an empty data frame. Final will be pd.dataframe, and this is just going to be empty. And then off of this final data frame, I'm going to create first the passenger ID, because I just want to look at the sample submission CSV file. As I see over here, there is sample ID, and then there is transported column. So for the passenger ID, what I'm going to be doing is just this of the test passenger ID. Actually, I forgot to see this. So what we have done is we have already dropped this passenger ID column while we need it right around now. So what we could do is create another sample dummy. df dummy will be pd.read to CSV, test CSV. And then from this test CSV, let's just get the passenger ID like that. And then our final transported, not so byte, will be our predictions. Just like that. And make sure that this is Boolean. And once that is done, now you can use the final data frame .toCSV function and then just create a submission.csv. Make sure to put index equal to false. As you look at the sample submission CSV, there is passenger ID and transported. There is nothing known as index because they use the passenger ID as index primarily. So when you now run this, you're not going to be getting a specific index for the data frame itself. Rather, we will be using passenger ID as our index. Pandas has no attribute of data frame. Actually, you will have to put this in caps like that and run this code out. All right, now it works. Now we should be having the submission.csv file over here. As I see, we get the submission.csv. I'm just going to give this as a submission and click on submit prediction. Drag and drop this submission CSV file. All right, and click on submit. And then it gives us an accuracy of 80.173. If you go to the leaderboard, then to your position, it puts us at around 768. And this is our very first submission. Now, if you could manipulate the data a little bit more, maybe create a new feature or something like that, but you can just further climb up the leaderboard as well. But that's about it. This video, I will be participating in the very first Kaggle competition that pops up for any brand new account, the Titanic Dataset machine learning problem. Now, for this one, you don't have to do any sort of verification or any sort of acceptance. You just have to get in there and then you can already submit your predictions. So first, as you click on the Titanic Dataset problem, it's just going to give you a deep description. And this is what I call as level 1. You have to gather as much information as you can before you even perform data analysis and pre-processing. So I have read this entire description. Basically what it says is we have to predict the people who are going to survive and the people who are not going to survive on the Titanic shipwreck. And so they've given us information about the data itself. They're going to give us a train test and then a sample submission file as well, showing us how the submission file should be. So in order to gather information about the data, you just click on the data tab, and then over here, when you look at the data dictionary, they have given us all of the different parameters and what they represent. So here's the one that we have to predict. We have to build a classification model that can classify whether a person has survived or not. And the other parameters giving us some conditional value as well. So right as I look at this one, these are the ones that I feel is going to give us values. Whereas if you come down and look at the actual data itself, if you look at the trained CSV data, we've got a name column, and this column is not mentioned in the data dictionary. So what I feel is we can drop this column itself. This is not going to give us any value in terms of predictions. And again, for me, this ticket column also has least amount of value, so I'm going to drop that off as well, because I've got more information from P class, and then I've also got the cabin number and then the ticket fare that they have paid. So I can just easily drop the ticket number, because it is only going to contain numbers and letters here and there, which is not going to give us any value. We already know the cabin number as well. Before performing any sort of analysis, I have understood that I can drop off ticket column and name column. Now, with that said, we can start off by importing all of these three files onto our local machine. Again, I want to show you the sample submission file. They're asking us for the passenger ID and then if they have survived or not. Our prediction should be the survived column, and then we have to give them the passenger ID. So we have to extract the passenger ID from test set, and then we have to create a new column survived as well. So with that said, we can just click on download now. That is going to install a zip file, and we will have to extract it to the main source. Alright, so now I'm here at Visual Studio Code, where I've created a brand new folder. I'm just going to call this Kaggle 001, and that is where I've extracted all of my data onto. Alright, so what I will do here is create a new file. I'm just going to call this Titanic model.ipynb. Again, this will be a Jupyter notebook, but then you can work with a .py file as well. But then if you want to use Jupyter notebook inside of VS Code, you have to make sure that you install that extension. Now inside of Jupyter notebook, I will be importing all of the dependencies. So initially, we will be needing pandas, numpy, and matplotlib. So make sure that you have it installed. And all of the others, I will tell you when we get there. So first, you just have to make sure that you have pandas, numpy, and matplotlib installed. I already have it installed. I'm just going to type in import numpy as np standard, and I'm also going to import pandas as pd, and then I will also import matplotlib as plc. I'm just going to have this code cell to be importing all of our dependencies, so I can just directly run this code cell. Alright, so once we have imported the initial three requirements, we can just first load in the data. I'm going to first put in the train data, and then I will also load in the test data as well. Train and df test like that. Df train will be pd.read underscore csv, which will take in train.csv. Then we will also load in the test csv as well. Now run this code cell. Now when you type in df train.head, this should show us the first 5 records. Yep, we see the first 5 records of the data frame train column. Let me just type in if survived, not in df test dot columns. Df test of survived will be, let me initialize everything to 0. Now notice what I've done here. I've created a survived column on our testing data because it's not already initialized. And the reason why I do this is I'm going to combine the test data frame and the train data frame together as a single domain. And this is very, very important. Whatever pre-processing you do, whatever data analysis you do, it has to come from the same domain. The train set and the test set should go onto the same domain. So what I will do here is actually we see the first 5 records. Now here I will create a new function. I'm just going to call this pre-process, and which will take in df test and df train. Alright, then what I will do here is call in df will be pd.concat, use the concat function. You have to make sure to put those two inside of list, df train and df test. Then make sure to type in axis will be 0, because we're just merging them in terms of columns. All of the columns are just going to be the same. We're just making that as one data frame. We're actually vertically stacking. Alright, now we have created our main data frame, and in this data frame only all of my pre-processing functions are going to go. So first, what I will do with this main data frame is I will drop off the columns that I don't need, and I will be doing that by using the df.drop function. I will drop off name and then ticket. Alright, so when I just type in df.drop name and ticket, those 2 columns will be dropped off, and that will update our main data frame. Again, in order to see this in action, you will have to call this pre-process function. In fact, let me just run this. This time we should not get any output. Yep. And first, let me actually concatenate this outside as well. Copy this,
paste it over here. All right, now we have a data frame outside and in the inside. This will go as a pre-processing function, and this will be for our reference. Now here, if I type in isNA.sum, this will give us the none values in each column. All right, now we see that we have none values in the age column, and we have those in the cabin column, and then we have a couple over inbox and one over in fare. So we will have to deal with all of these, but before that, I want to show you, after dropping the name in the ticket column, how does the data look. So what I will do here is, let me just go ahead and type in reference. df will be just calling the pre-process function, and then which will take in df train and df test, like that, and this will give us the final data frame. So let me just return that as well. Return df like that, run this code cell, and now run this reference df.head. When you run this code cell, you should be able to see the dataset without name and without ticket. So this is after dropping the name column and then the ticket column. All right, the next thing that I'm going to do is deal with these none values. And the way I'm going to do this is by filling off those none values based upon some conditions. Like, let's say for age, I'm just going to fill them off with the mean value. So what I will do is type in df of age will be df of age, once again, dot fill NA. This will fill the none values. This is the function responsible for that. And then we have to mention the value with which we are going to fill the none values. And I'm going to be identifying the mean of the age. So dot mean, and that will be it. It will be filling all of the none values with this age. All right, so let's just run this code cell once again and make sure that this is also working. Reference df dot isNA dot sum. Run this. You should be able to see no none values in age. Now for the cabin number, what I can do is, first, if you look at the cabin number itself, you can see that it has got a letter and then it has got a bunch of numbers. So I will be filling it in that format itself. This is not in the format of numbers. This is in the format of string. So we have to fill it in the format of string only. So what I will do here is just go ahead and type in df of cabin will be, again, just do the same thing, fill NA df of cabin, but this time I will be just typing in x000. That is a random letter and then zeros. All right, now let's just make sure that that also works. We do this, and now we see that we have no none values in cabin as well. We can do that for embarked. I'm just going to find the median of embarked, because let me just show you the data. It's just showcasing the letter, so we can find the median of that and then fill it. So what I will do is just go ahead and type in fact, let's just delete this data. Alright, now here I'm going to just type in df of embarked will be df of embarked, once again, dot fill NA with actually finding the median. So df of embarked dot median. Actually, you know what? Instead of finding the mean, I feel like we're much better off with just filling it with a random letter. Alright, so let me just fill it with x, and then we also have fare as well, which I will be filling it off with mean, like that. Now when we just run this code cell, again, I just fill the none values by finding the mean of fare column. Alright, so now that I've done that, now we should be seeing no none values in any column. So let me just run, okay, first we had to call this and then call this. Alright, now we see that we have no none values anywhere. Now the next thing that I'm going to do is actually separating the cabin itself, and then when you look at some other columns as well, we've got binary values, male and female, and then over here we've got 3 different values, SC, and then if you look at it further, you're going to get much more letters as well. And then in cabin, we will be having multiple different values, and we will have to separate them accordingly. So what I think of doing is just performing one hot encoding. But before performing that, I'm going to separate the cabin values from its letters. So I will be creating 2 new columns. One will be for the cabin letter, and the other one will be for the cabin numbers. So in order to do that, what I will do here is just go inside of the preprocess function, then type in, let's first create 2 new columns, cabin letter will be, and then I will also create cabin number. Alright, so we have created 2 new columns. The first column will hold all of the letters only. So to extract that, we can use regular expressions. In order to do that, let me just first access the cabin column itself. This is the cabin column. I'm going to first convert that to string, just make sure that it is in the string format, and then type in extract. You will have to mention the regular expression. Since you're only going after the letters, what I will do here is just type in from A to Z, and then also capital A to Z. All right, or just make sure to put in plus. This will look for multiple different continuous letters, and if it finds it, it's going to extract it and put it in cabin letters. All right, I'm going to also type in expand equal to false because we're going to do it anyway. And then I will do the same thing for cabin numbers as well. What I will do here, just get here, then type in \d. This will look for digits and then extract that, put that in the cabin number column. All right, now we have created that. Again, we just make sure to run this and check if everything is working properly. Reference df. Oops, pattern contains no capture groups. I guess we have to put this inside parentheses. That, I like that. Yep, now when we run this code cell, run this. Oh, we have to do it for this one as well. Now this time it should work. Yep, it works. Now we should be having two new columns, cabin letter and cabin number, which has extracted the letter and the number separately. Now we don't need this column anymore, so I will drop that off as well. What I will do here, come here, and df will be df.drop cabin, and then I will mention axis equal to 1. All right, so we've mentioned that. Now let's just run this code cell once again. All right. Now we don't see the cabin column itself, but then we see the cabin letter and the cabin number as two separate columns. Our model will like complexities like this. It will understand the data better. All right, so the next thing that I'm going to do is one-hot encoding all of the different categorical values. So here, as we see, like in terms of this column alone, we have two categories. One is male and the other one is female. So what I can do is create two new columns, male and female. And if the record belongs to male, then the male column will have 1 and the female column will have 0, and vice versa. And we can also do this for the embarked column, cabin letter column as well. So this will give us multiple different new features, and off of those features, we can remove all of the non-value column as well. That is, if the cabin letter X column is 1, we can drop off cabin letter X. That is, we don't need the cabin letter X. While all of the other values are 0, then cabin letter X will be 1. Again, I will show you how this works when we get there. So first, let's just do the one-hot encoding itself. And the simplest way to do that is by using panda's getDummies function. So what I will be doing is typing in pd.getDummies from the df itself, the main data frame. Now we can type in columns equal to cabin number. And then we can also add in a prefix, which will be cabin, like that. Instead of cabin number, let me just put this as cabin letter, like that. All right, and make sure I put this inside a list. All right, I'm also going to do this for embarked as well. So let me just create one for embarked, prefix as well. Let me just change this to embarked. And then I will also do this for the gender column. So Control E, all right, like that. Now, when we run this code cell alone, after these 3 lines, we have to see a significant difference in our data set. All right, now we see that we have multiple different cabin columns. This will say if the person belongs to cabin A, B, or C, and it just goes on. And if they don't belong to any of these cabins, if the data for these cabins are not available, then cabin X will be true. And what I said before was to just drop off this column itself. Let the machine identify that if the information for all of this is not available, then it's just 0. We can't get any data out of it. All right, the same goes for embarked as well. If embarked X is true, then we can just drop off that embarked X as well. Let the machine identify the same as it did for cabin as well. All right, now what I will do is just drop off those 2 columns that I just mentioned. df will be df.drop, guess it's called cabin X. Axis will be 1. Let me do that for embarked as well, embarked. Now let's just run this code cell once again, and this again. Now we should not be seeing the X column existing. All right. Yes, we don't see the cabin X column here, and we also don't see the embarked X column here as well. All right, the next thing that I want you to notice is when we initially look at the original data, in fact, let me go ahead and over here, let me just type in dftrain.head. Here we see the cabin, and it's got C85. Let's say that this is an example where it's got letter and then numbers. What if cabin only contains a letter and then there is no numbers? There's 4 records like that. I've looked at the data by just performing that earlier, and then I found out that 4 records has only the letter and it doesn't have any numbers. Now what happens is, when we split the letter and numbers separately, we will have the letter column filled, but then the numbers column will be none. So now, if you actually have to look at it, just run this console, we see that the cabin number has 6 none values. When we combine the test and the train set, we get 6 combined none values in the cabin number. And we can just fill this with 0. So what I can do over here is just access the cabin number column, will be cabin number dot fill NA with 0, just like that. That's about it. This should fill the cabin number which has none values. So let me just run this code cell once again, then run this as well. Alright, now we see that our cabin number has no none values. Alright, so after all of that, now we have a pretty feasible data set with just pre-processing and cleaning itself. Now, if you look at the final data set, in fact, let me just run this once again and this as well. We get a data set that we can provide to the model for predictions. So let's just try that. Before we even do any feature engineering or anything like that, let's just see how the model performs on our just cleaned and little bit of pre-processed data set. So what I will do here is, notice that we have concatenated the train and the test set together and then made that as df. Now in the return format, I will be returning that as train and test once again. Because test set, remember that we have crafted a new column survived and then we have initialized all of it to 0. So what we have to do here is just get the train set and then ask for the model to train on that, and we have to deploy the model on that training set only. So what I will do there is just first, after extracting this training set, I will split that into 80 and 20, where 80% of this training set will go to the model for training, and then 20% of this training set, we will use it for testing the model. Right, so df of train, this will be our return format. Df of, from starting till the then of df train, the first train values is what we're going to get as our train set, and the rest is going to be our test set, like that. And then before returning that, what I will do is I will drop off the column df of test, will be df test dot drop survived, because we don't need a survived column, it has to be non-initialized, we have to predict on that. Alright, let me just mention access equals 1, like that. Alright, now I'm going to return df train and df test like that. Now run this code cell, that is our pre-process function. Now this will get our df train and df test back. So let me just write it in reverse. Df train, comma, test data frame will be this. Cancel this thing out and then delete this one as well. Alright, now when you just run this code cell, we're going to get train df and test df. Alright, now from the train df, I'm going to extract our x and y labels. So our x will be train df. Actually, let me just do that in a specific separate code cell. We'll come over here, just do that in a specific code cell. Df x will be, our x label will be train df dot drop survived column, because we want all of the data without the survived column, and then access will be 1. And then our y label will be train df of survived column, of survived, like that. Alright, so now we have our x label and our y label. Now I will do the train test split. Now from this point on, we will need scikit-learn. And you can just go ahead and type in pip install scikit-learn on your command prompt, and then it will install the package for you. So just go to your terminal and then type in pip install scikit-learn. So what I'm going to do here is just go ahead directly and type in from sklearn dot model underscore selection import train test split underscore so. Alright, now we have our train test split installed. This will be the function that we'll be using to split the data into 80 and 20. I'm just going to call this x test, actually x train, comma x test, y train, y test. All of these 4 columns, which will be, we will call our train test split function, train test split, which will take in x and then our y label. Let me have my test size to be 0.2. That should work. And then now let me just run this code cell once again. Now if you type in x train dot shape, comma y train dot shape On this, we have 712 records on both sides, but then we would like to have this as two-dimensional. So what I will do here is just type in, actually, inside of this, let me go ahead and type in yTrain.reshape. Let me just go ahead and type in yTrain. Will be, let me update that to np.reshape function and then use it yTrain. Now we will also have to mention the size. We can have as many rows as we wish, but then we have to make sure that there is only one column. Let me close that and run this. All right, now that works. Now when you run this, we get a two-dimensional shape. Now, from scikit-learn, I will be first importing the logistic regression model and see how the model is performing. So from sklearn.linear model, we want to import logistic regression. All right, now update and run this code cell. Now we will use that. That is our model 1 will be, this will be our first model, logistic regression. And then I will type in model1.fit to pass in our xtrain and ytrain, like that. After we've done this, let me actually run this code cell. All right, now when we see this logistic regression, that means that the model is created. Now we can make predictions on this. Now, all we have to do is just type in model1.predict, and then we have our xtest variable. Now this will give us predictions in terms of ypred, and we can compare that with our original labels, and we can do that by using the accuracy score from scikit-learn. We will have to import that one as well. So we get to the cell where we import all of our dependencies. So from scikit-learn.metrics, we will import accuracy score like that. And run this code cell. I have imported the accuracy score, and then let me just go ahead and type in accuracy score of ytest and ypred. We have passed in the original variable and then the predicted variable as well, and then we can see the accuracy score. And when you run this, oops, ypred is not defined, we have to run this, and then we have to run this. All right, so we see that the model is giving us 80% prediction without doing any feature engineering. I consider this a fairly decent one, but then I feel like this could get better. So let me just try that with another model. Let me actually use XGBoost this time. Again, you have to install XGBoost as well, but I have already done that. If you haven't, just type in pip install XGBoost on your terminal. Again, if you haven't done that, just go to your terminal and type in pip install XGBoost. This is another library which uses decision trees to perform classification tasks and also regression as well. But for this one, we will be using XGB classifier. Since I already have it installed, I'm just going to directly import it from XGBoost. We will import XGB classifier. This one. All right. All right. So now we have imported the classifier. Let me just create another new model. It's just very similar to what we have done above. Just go ahead and type in model2 will be XGB classifier. And then we can just go ahead and type in model2.fit xtrain and ytrain, like that. When you run this, we get an error. Enable categorical must be set to true. All right, so let me just go ahead over here and just type in enable categorical will be equal to true, like that. Now when you run this, we should be able to see the model itself. Why is it not working? Okay, so instead of trying this, instead of typing in enable categorical equal to true, we know that we only have floating point numbers as our cabin number. What we can do is just convert this cabin number to maybe, let's say, a panda's numerical object. So to do this, what I can do is go over here. df of cabin number will be equal to pd.toNumeric. This will now be a numeric object of cabin number, like that. Close it. All right, so now we have converted the cabin number to a numerical value and then stored that to our cabin number column. This should now be working. So let me just run this and then run this. Now if we see our model 1 predictions, it gives us 87%. Okay, so when we run it multiple different times, you will get a mean value of how the model is performing on the test set. But then I've done that just to rerun the file to convert that to numeric. Now, yes, we do get the XGB classifier model as well. Now what I'm going to do is just go ahead and type in ypred is equal to model2.predict xtest. All right, tab 9 recommendations. All right, and this one as well. All right, now when you run this, so our model 2 gives us 82% prediction, but I feel like we could do a little bit of feature engineering and get this up as well. But then, just for the sake of it, I'm just going to run all once again and see the accuracy score. For model 1, it is 78% this time, and then 78% for this one as well. So there is a lot of noise here and there. So what I wish to do is give it more obvious features for the model to actually identify the conditions or the value proposition of each and every feature. Again, if you don't understand what that means, I will show you right about now. All right, so what I will do here is we have got the train df and the test df. So here I want to find out from the train df, I want to find the correlation of all the models with the survived column. That is, how much value is it providing to the survived column. And to do this, what I will do is type in df.core. This is a function which is to identify the correlation, and then you have to mention the column as well. All right, and this is not df, it will be train df. When you run this code cell, you will see the survived column as a 100% relation to the survived column that you mentioned, which is very obvious. So that is how correlation works. I want you to look at p class. Now when it says negative, that means that more smaller the number, more chances of the actual column that we're trying to predict is 1. So when the p class number is low, it gives us a 33% indication that the person might survive. That is how we find a correlation of each and every single column that we've got. And then from over here, we see that the very strong indicator is p class. And then I also see that the gender part for some reason gives us maximum correlation as well. And then I also see cabin number, which is okay-ish. We see the cabin number, and if it's higher, we get a more good chance of the person is going to survive. We also look at the fare, more the chances of them surviving. All right. Now with this data, with this information, I will be crafting new features. And the way I do this is by looking at all of the ones that give us maximum value. And I see that, let me first look at this one. This is p class, and we can correlate that to fare. That makes more sense. All right. So I'm going to combine these two columns, p class and fare, and create a new column. I'm going to just call this p class bin underscore fare. All right. And this will be df of p class, or let's say fare, and I will divide this by, all right, so I'm just obtaining the fare, and then I'm also obtaining the p class as well. That is the fare, let's say if it's 1000 units, and then if the p class is, let's say 2, if we divide that, that's going to give us a number of 500. So this should give us a positive correlation, or maybe negative. That doesn't matter, the number should be big. All right, so now when I run this code cell, and then run this one, and run this one, now we see that we have a new column, and that correlation has 26%, which is actually really, really nice. This is giving us positive indications to the model itself that it can make better predictions. Now, on this side itself, let me just create another feature, p class, let's say p class bin, and then I can access the gender as well. And as I see over here, that it says that if the person itself is a female, then they have 54% chance of surviving. So what I can do is, we have created two categorical columns, one for female and one for male. So if the female column is 1, we can just subtract that from p class, because that is going to give us a realistic number. I'm just making these correlations up. You can try dividing it, you can try multiplying it, you can try any type of method that you wish. For the first one, I divide it, and for this one, I will be subtracting to get a single valued number. I'm just thinking it with an example in perspective. All right, so p class minus female, or what is it called? Just copy this, paste it over here. All right, now we've created another new column, and this should again give us a strong indicator as well. Why is it taking too long? Gives us an error saying p class is not found. Okay, type it like this code cell, on this one. And now run this. Now we get 2 new columns, and this as well is giving us around 53% of strong indication to identify the final variable. All right, now this time, after constructing 2 new features, let's try that with these 2 models. Just make sure that they are of the same shape. All right. Now create a logistic regression model, make predictions, and see the prediction rate, and it's giving us right around 80%. Let me just do that for model 2 as well. and then identify, and still it remains at 78%. Let me just run all once again. Alright, it keeps going further and further, and still we can't reduce the amount of noise. So we have to continue to identify all of the new features that we can create. But then for the time being, I'm just going to leave it as it is. Maybe I will construct 2 new models as well. So we will create model 3 and model 4. And over my knowledge, we can also use random forest classifier. Again, that is another one which uses decision trees to identify classification. And this is pre-built in scikit-learn itself. So again, from sklearn.ensemble import random forest classifier. All right, like that. Now run this code cell. We'll create our third model. Model 3 will be random forest classifier. Model 3.fit takes in xtrain, comma ytrain, like that. This should take in some time. Yeah, all right. So we have the random forest classifier model as well. Let me just try to predict for that one. .predict xtest, and then we can predict the accuracy score for this one. All right, now let's just run this code cell, and this gives us 83.7%. Let me just run that once again, and this time it gives us 84%, while if I compare that to, let's say, model 2, it's giving us 81%, and this is at 78%. So when I compare that to the first 2 models, let me just do that once again just to be absolutely clear. All right, so this is always about 80s, while this one fluctuates around the low 80s and the high 70s mark. So I'm just going to go with model 3, that is the random forest classifier model with the provided data, and then I will make predictions with that. So inside of this code cell, what I will do is create a new CSV file which will extract the passenger ID. Again, just remember that the submission file format should have the passenger ID, and then it should also have the predictions. So to do this, what I will do is, again, update the prediction variable model3.predict xtest. Instead of xtest, let me just pass in the test df. All right, we have our test data frame. Notice that we extracted that from the preprocess function. If I could show you, it's right around here. We have extracted the test df, and then we are going to identify the predictions for those by using the model 3. And then let me just give it a name. Final will be pd.dataframe. So create a blank data frame. All right, so inside of this final, we'll first have passenger ID, which will be extracted from the testing data, will be equal to test df of passenger ID. All right, now we have our passenger ID, and then final of survived column will be our prediction. It's like that. And then to just simply create a CSV file, you can just type in toCSV function, which I will call it as output.csv, and then I will mention index equal to false, because our index is just going to be the passenger ID which we have created. We don't need a random index. All right, now when you run this, we should be able to see a new output CSV. All right, we get that over here, and then this should match to the passenger ID and survived column. All right, so now we have this output CSV. We're going to make this as a submission and see our results. Now over here, we will just want to click on submit predictions. I will drag and drop the output CSV file, or output.csv, click on submit, and this will give us a leaderboard. All right, so now it gives us a score of 76.55%. If you look at that on the leaderboard, jump to your position on the leaderboard, we will find us somewhere on this column. And now when you look at the top percent in the leaderboard, we see that there is 100% accuracy, which I feel like is forced. I don't feel like this is realistically possible. A model will never be able to predict 100% of the data unless it is provided much more data than we actually had. In fact, if I have to go to my main account and show you my initial predictions, I was able to go as high as 79.186%. If I look at that in the leaderboard, that will put me at around 1076. Again, so this can definitely be improved. You can create much more new features, and then you can also try different models as well. There's again a decision tree classifier and support vector machine and much more classification algorithms that is there in scikit-learn itself. And then you can also nevertheless just create multiple different new features and also try to understand the data a bit more. I will also provide the data file that got me 79.186 in the description box below. All right, that's about it. Alright, so I hope that you got a good understanding of how to solve Kaggle problems in general. And according to me, these 3 projects are just merely perfect for you to getting started and get going to the next level where you can actually think about solving more advanced Kaggle problems. Again, I urge you to check out SMDS, where we will continue on with this Kaggle series, posting end-to-end full guide videos and Kaggle competitions, and it scales from beginner level all the way up to fully mastering Kaggle competitions itself. And on top of that, we also post many other machine learning videos that includes data science, that includes generative AI and whatnot. And again, as I promised, I will make sure to leave a link to our entire Kaggle series playlist in the pinned comment below. Alright, so that's about it for me. I hope you enjoyed this video. We will see you there.